So I'm going to explain 2.3, the second part of this video. We'll see if I can finish these notes in this video. And what I decided to do is just look at the answer key to explain the derivative of sine and cosine. I recognize that this is very busy, but in the previous video I explained graphically why the derivative of sine is cosine and the derivative of cosine is negative sine. So you can skip ahead in the video if you feel confident with that. Because if you're going to do this algebraically, which they will never ask you to do on an AP test, this is more knowledge for you, you need to understand that the limit as h approaches 0 of 1 minus cosine of h over h is equal to 0, and the limit as h approaches 0 sine of h over h equals 1. These are things we did in chapter 1. You also need to know these trig identities, which is something you probably saw in pre-calculus, maybe even algebra 2, and you need to reference them when you're proving this. So let's look at sine. I'm not going to explain cosine, but all the work is right here. So the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. And so what you have to do is replace sine of x in for those pieces. So you can see sine of x plus h replaces here, sine of x replaces f of x, h stays here. So using this identity right here, we can replace sine of x plus h with sine of x cosine of h plus cosine of x sine of h. And what you need to be smart about is that you can move things. Move sine of x over here and then factor out a sine of x cosine of h minus 1 all over h. And then you still have this cosine of x sine of h over here. So now what you can do is rewrite the limit twice. Now remember, that's a property of limits, that you can do the limit of the left one plus the limit of the right one. They equal the same thing. So the instructor highlighted the limit as h approaches 0 of cosine of h minus 1 over h is equal to 0. Well, 0 times anything left over is equal to 0. While as over here, what he highlighted in yellow, limit as h approaches 0 of sine of h over h is equal to 1. Times cosine of x is cosine of x, and 0 plus cosine of x is cosine of x. You can probably see why I don't expect you to know this, why the AP test doesn't expect you to know this, and why I'm not even going to talk about this work on the right side to explain the derivative of cosine. But at any point, if you wanted to stop the video, pause, and write it down, you could probably just Google to get these correct answers, and you would be just fine. So if you want to continue on, you might want, or write all this down, you might want to hit pause before I move on. So what we're going to do now is we're going to write the equation of the tangent line, and we're going to get the exact answer. Now remember, if you're writing the equation of a tangent line, you need a point and you need the slope. Now how do you find each of those? Well, they give you the x value for the point. You might want to figure out the y value of that point. Well, that's pretty easy. You can just plug in x all over the place. Well, I'm going to look right here, because negative 1 plus 1 is 0, squared, still 0, times whatever this is, I don't care, still 0. So I have the point. Now let's find the slope. Well, how do you find the slope? You need the derivative. So what I would do, because for me it would be easier to multiply this out, x squared plus 2x plus 1, and then take the derivative. So now I'm looking at 2x cubed. Let's see, you get 4x squared minus 1x squared. And then we have, what's that, 2x minus 2x. So that'll cancel. I'm going to double check that I'm right before moving on. Yep, I think I'm good. So then the derivative of this is 6x squared plus 6x. But even that's not good enough. You need to figure out what f prime of negative 1. You need the slope at that point. Well, negative 1 squared is just 6, and then minus 6. So the slope at that point is 0. So putting it all together then, we can say, okay, y equals the slope, which is 0, x minus your x coordinate, plus your y coordinate. And that would give you the equation of the tangent line at that point, which you might be just thinking, oh, Why couldn't you just write y equals 0? You're absolutely correct. That's actually how I would write it. So let's look at the next one. Okay, so first of all, we need the point. Pi over 2, that's the, well, it's theta, but it's the x-coordinate. It's the independent variable. So let's look at this. Well, if I were to figure out what f of pi over 2 is, well, sine of pi over 2 is 1. So we're looking at 4 times 1 minus pi over 2. And you can just leave it like that. That's your y-coordinate. All right, well, now let's find the derivative. And it's actually set up pretty nicely for the derivative because we know the derivative of sine is cosine now. And the derivative of theta is 1. You remember, the derivative is just x. The derivative of x is 1. Well, now I can say, well, what's f prime of pi over 2? Well, cosine of pi over 2 is 0, so 4 times 0, 0 minus 1 gives me negative 1. So as I'm writing the equation, y equals my slope, the negative 1, x minus the x-coordinate, and then plus the y-coordinate. I meant to change colors, but I hope you're okay. I left it as green. For anybody that's curious, or if you're checking an answer key, you could actually simplify this quite a bit, because what you would see is you'd have a positive pi over 2 with a later negative pi over 2. So the answer actually does just simplify to negative x plus 4, if you wanted to do that, but that is oversimplifying. I shouldn't say oversimplifying, but it is correct. Same thing with the next one. So your x-coordinate is pi. As you plug in pi in for this, we have 2 pi plus, well, cosine of pi is negative 1, so 3 times negative 1. So we're looking at 2 pi minus 3. So here's the ordered pair. So now what we need is g prime of theta, which equals 2. Now the derivative of cosine is negative sine. That 3 just kind of goes along for the ride. And sine of pi is 0. So I hope you're okay that I just write equals 2. So then the equation of the tangent line equals the slope, and then x minus your x-coordinate, and then plus your y-coordinate. And this is acceptable. But I'm sure if you're looking just like the previous problem, you might be looking at that and saying, oh, I see, I distribute, I'd get a negative 2 pi plus 2 pi, so they would cancel, minus 3, that would be correct as well. And let's look at this next one. Again, you need the point. 2, well, plug that in, 2 times 2 is 4. Let's see, I think it's just going to be 2 cubed is 8 and the square root of 8. And you can just leave things unsimplified. There's nothing wrong with that. Now, as far as h of x, it might be worthwhile to realize that, to the first minus, this is the 1/3 power. So it might be worthwhile to rewrite it as to the negative 2/3 power. So why is that useful? Is now you can say, well, the derivative would be negative 4/3 x to the negative 5/3 power. And then when you plug in 2, it's not going to be a pretty number. But I'm going to jump to that value. The slope would be negative 4/3 times 2 to the negative 5/3 power. See how sometimes your answers just aren't that nice? Sorry, that's a plus. And I'm sure if you want to, you could clean that up if you want. But I'm trying to get this video done in this time slot. The next part, and the last part, is a horizontal tangent, which I've warned you about. What needs to happen to have a horizontal tangent? The slope must be 0, or the derivative, I guess, should equal 0 and solve for x. And that's exactly what they're going to ask you for. What values of x will this have a horizontal tangent? Well, take the derivative. You get 3x squared plus 1. And you want to set that equal to 0. Well, as I'm looking at that, and I subtract 1 and divide by 3, well, you can't square root a negative. So this means there's no horizontal tangent. And maybe what I'll do is pull up the answer key just like I started this video with, and let you pause, as you see fit, and write down these things. And it explains a little bit more detail about a horizontal tangent must have a relative max or a min. Now, it doesn't always have to, so I would hate to commit to this statement. You can have a horizontal tangent that is not a max or min, but it's still true that the derivative equals 0. All right, so I'm kind of hesitant to commit to that. But again, pause the video before I already did. So here's another problem. A horizontal tangent means the derivative needs to equal 0. So the derivative of this is 1 plus cosine of theta. You set it equal to 0. Well, if I solve for theta, I need to think about, well, where does theta or cosine equal -1? On the unit circle, it is over here at pi radians. So at pi radians, this function has a horizontal tangent. Again, I can show you the work, and then he kind of goes into a longer explanation. But again, it's not actually a relative min or max. It's what we call a point of inflection that we will get into in a little bit later in this chapter. It might even be the third chapter. But again, pause the video if you need to write anything down. Otherwise, I think I'm ready to assign the homework.